Let's review some of the key features of logarithmic functions. The most obvious, I think, is the fact that it goes up forever in the y direction and down forever in the y direction, right? There's no limits to the range. So we say negative infinity, positive infinity. But in terms of the domain, there certainly is a limit. It's this vertical asymptote right here on the left. You can see it's sticking out like a sore thumb. The function can never go past that vertical asymptote. And what that represents is you not being able to take the logarithm of 0 or any negative numbers. It's forbidden. Those are domain restrictions. So we would just say, well, -2 is as far negative as I can go, and then out to infinity on the right. Okay, so that's domain and range of a natural log. You can also think of this right here as an indication of the horizontal shift, okay, if you like transformations. And let's move on to the x-intercept. I like talking about x-intercepts and y-intercepts because it gives us a chance to review some basics. The way you find the x-intercept is you set y equal to 0, right? If you look at what we are talking about here, this is the x-axis. Where does the function touch that? Well, at the location y equals 0. That's where that dot lies. I'm going to find the x location by solving the equation. So we say 0 equals -2 natural log x plus 2 plus 3. And now I'm going to solve this by trying to isolate the logarithm. Okay, so that means 2 log x plus 2 gets moved to the left. I still have that plus 3 on the right. Divide each side by 2 equals 3/2. And then I'm going to take each side raised to an exponential power. So e to the natural log and e to the 3/2. You might think, what is going on here? Well, remember that exponents and logs are inverses of each other. So this is a nice little property where those cancel out as long as they're the same base. If you're more comfortable with it, you can think about it alternatively, which is me saying the following. Instead of raising each side to the exponential power, I'll just remind you that the base right here is e. So I'm going to do this little swoopty thing that we do in class. E raised to that power equals the thing in parentheses, which gives me exactly the same thing as I was just talking about. E to the 3/2 equals x plus 2. Okay, now we subtract 2 from each side. We get e to the 3/2, e to the 3/2. E to the 3/2 equals, -2 equals x. Now that's the x-intercept right there. So I would say my x-intercept in the following way. I would say x-intercept equals, parentheses, here's the x-coordinate of it, e to the 3/2 -2. I know that looks gross, but it is just a number. And from the looks of this graph, it's a number somewhere between 2 and 3. So there we go. That's how you find the x-intercept for these guys. Now the y-intercept, same exact method. Okay, I'll just point out that the y-intercept is where x equals 0. Okay, so for this guy, I'm going to say y-intercept, our method is set x equals 0. And we're going to solve this equation. Now what was my equation here? It was it was y equals -2 times the natural log of x, for us that's 0, plus 2 plus 3. Okay, well, that's it, right? It's as easy as that. Y equals -2 natural log of 2 plus 3. And it looks ugly, but that's simply what we have. So I would say this in coordinate form by saying 0, that's the x-coordinate, comma, -2 natural log of 2 plus 3. Okay, that's that. Now, in this particular example, I did have a y-intercept, but it's possible you might not, right? If your vertical asymptote was something like this blue line that I'm drawing, and your function exists to the right of that, in your case, well, no y-intercept there. Or if you had a horizontal reflection, and maybe your function looks like this, and it goes off in the other direction, right? No y-intercept there either. So keep an eye on the graph as a way to ground yourself and know whether or not you actually have x and y-intercepts. Now, in terms of the local max and mins, these should be very quick. If you understand what local, or for that matter, absolute max mins mean, no matter where you are in this graph, I could say to you, if you think blue is the minimum, right? I'm going to say, nope, the red one is. And if you think red is the minimum, I'll say, nope. How about this one over here? That's even lower. And we could play this game for a while because the function just drops down to infinity. So there's no absolute minimum. There's no local minimum. There's none of that. And likewise for maximums. So there's none of this to worry about with a regular logarithmic function or a transformed logarithmic function. At least none of these types. And then in terms of where this thing is increasing, well, look at that. It's downhill all the way. So in this case, we say nowhere. But excuse me. It's not increasing anywhere. And this looks like a repeat line, so we don't need to worry about that. But in terms of where it's decreasing, well, that's everywhere. Just don't make the mistake of saying negative infinity to positive infinity. Okay, because the function doesn't actually exist everywhere. But everywhere the function exists, it is decreasing. So by that I mean starting at the vertical asymptote and going to infinity. Okay, that's the full domain of the function, and across the entire domain, it is decreasing. Likewise, this is not constant anywhere. It's not flat. It looks like it gets a little more shallow at the edge, but remember, that's still downhill, even if it's not steep. And then in terms of where is this positive, where is it negative? Well, take that x-intercept, okay, and just think about all this stuff right here. All this area of the curve, this is all positive. And over here, these are all places where the y values are negative. So we just have to say that in interval notation. I would say positive goes from, well, where's that x-intercept? It goes up to there. So that's going to be e to the 3/2 minus 2. That's as far to the right as I can be while still being positive. But on the left side, I'm bounded by that vertical asymptote at -2. And then where is it negative? Well, again, that x-intercept, e to the 3/2 minus 2. But then it goes out to infinity because the function just goes on forever.